Day 3, Problem 1. A ladder is leaning against a wall. Its base is 6 feet from the wall, and it reaches 15 feet up the wall. Part A, sketch a diagram of this situation, and Part B, use the Pythagorean theorem to find the length of the ladder. So I need to have a wall, and for that, just a vertical line. And then across the bottom, this could be the ground. And now a ladder leaning diagonally against the wall. It might look something like this. Now this diagram in math is a triangle, and it is a right triangle. There is a 90-degree angle in this corner here. Now we're told in the problem that the base, or the bottom of the triangle, is 6 feet, and that it reaches 15 feet up the wall. That is this leg of the triangle, 15 feet. And what we're asked to figure out is how long is the ladder. We don't know how long that is, and so we can use a variable to represent that. Now I could pick any letter of the alphabet I want, but because in Part B I'm asked to use the Pythagorean theorem, which involves an A and a B and a C, I'm going to use the letter C on the ladder because that is the hypotenuse of the right triangle, and the letter C is the letter in the Pythagorean theorem that's used for hypotenuse. So this diagram takes care of Part A of the question. Now Part B, use the Pythagorean theorem to find the length of the ladder. The Pythagorean theorem is A squared plus B squared is equal to C squared, where the letter A is the shortest leg of the right triangle. In this triangle, the shortest leg is this side right here, 6 feet, and that can be filled in for A. The letter B in the Pythagorean theorem is the next leg of the triangle, which is this side here with the 15 on it. So 15 can be filled in for the letter B. And that is equal to the hypotenuse squared. And the hypotenuse is the ladder itself that has the letter C on it. So C squared. And so here is an equation that we can solve for the letter C to figure out what C is equal to. 6 to the second power is 36. 15 to the second power, 15 times 15, is 225, and that is equal to C squared. Now adding these two terms together, 36 plus 225, we can figure out what that makes. So 225 plus 36, doing a little bit of scrap work over here on the side. 5 plus 6 is 11, carry the 1. 2 plus 3 is 5, plus 1 is 6, and bring down the 2. That is 261. So 261 is equal to C squared. Now I want to solve for C, so I need to remove this exponent of 2, and the way that I can do that is using a square root. So on the left side of the equation, the square root of 261, and again on the right side of the equation, the square root of C squared. Now figuring out the square root of 261. If we had a calculator, we could certainly type this in, use the square root button on the calculator, and get an exact answer, or perhaps this is some sort of decimal that we might need to round off to 1 spot or 2 spots. Without a calculator, the best we're going to be able to do is take a good solid guess at about how much the square root of 261 is. Let's see. What about 15 squared? How close does 15 squared come to 261? Well, you might recall that earlier we had figured out 15 squared was 225. That's less than 261. But what about 16 squared? So a little bit of scrap work. What is 16 squared? 16 times 16. 6 times 6 is 36. Carry the 3. 1 times 6 is 6. plus 3 is 9. Start the next row with a 0. 1 times 6 is 6, and 1 times 1 is 1. And then add these two rows together. 6 plus 0 is 6. 9 plus 6 is 15. Carry the 1. And 1 and 1 is 2. 256. 256 is very close to 261. It's still not quite large enough, but I know from my answer that it's going to be larger than 16, but I don't think it's going to be all the way to 17, because 17 times 17, no doubt, is much larger than 261. Let's figure out what 17 times 17 is. So 17 times 17. 7 times 7 is 49. Write the 9 and carry the 4. 1 times 7 is 7, plus 4 is 11. Start the next row with a 0. 1 times 7 is 7. 1 times 1 is 1. And then add these rows together. So 9 plus 0 is 9. 1 plus 7 is 8. And 1 plus 1 is 2. This is 289. That is larger than 261, quite a bit larger than 261. So the square root of 261 has got to be more than 16, but it does have to be less than 17. So it's going to be some sort of decimal, 16 point, and then we can take a guess at what digit might be in the tens position here. Now, 261 is not exactly halfway between 256 and 289. If it was exactly halfway, then a good guess for the decimal would be a 5, right? 16.5. 0.5 represents a half. But it's not halfway between 256 and 289. 261 is much closer to 256 than it is to 289. So how about guessing a digit that's less than 5? Perhaps guessing a 1 or a 2. I'm going to guess a 2. 16.2 is my decimal approximation of the square root of 261. And on the right side of the equals, the square root of c squared is c. So c is equal to 16.2. And in our original question, that is this side of the triangle, which is the length of the ladder. That is 16.2 feet. Now, day 3, problem 2. Graph figure ABC with vertices A, 5, 2, B, 3, 4, and C, 1, 1. That's going to create a triangle on this grid. And then in part B, we're asked to create the reflection of that triangle by reflecting it over the x-axis, by flipping that triangle to the other side of the x-axis. And then in part C, we're going to determine the coordinates of the vertices of that new triangle. So let's tackle these one part at a time, starting with part A. Point A is at 5, 2. So starting at the origin, 1, 2, 3, 4, 5, and then the second number was 2, 1, 2. Here's a dot, and this is point A. Now point B is 3, 4. So starting at the origin, 1, 2, 3, 1, 2, 3, 4. Here's a dot. This is point B. And now point C, 1, 1. Again, starting at the origin, over 1, and up 1. There is the dot. That's point C. Connecting these together, we can see the triangle ABC. Now, in part B of the question, we're asked to create the reflection, which we're going to call A prime, B prime, C prime. And this reflection is going to be done over the x-axis. So the first thing I'm going to do is highlight the x-axis so it stands out very clearly. The x-axis is this line here running left and right across the middle of the grid. So I'm going to highlight that in red ink. Now, reflecting a triangle over a line means to redraw the triangle on the other side of that line. And I can do that by carefully moving from each of these three dots to the red line and keep track of how far I move to the red line, and then continue on the other side of the red line that same amount. So let's do this, starting with point A. I'm going to travel straight to the red line. 1, 2. Point A is 2 units above the red line. Now I'm going to go 2 more units. 1, 2. Here's a dot. This is 2 units below the red line. And this is A prime, the reflection image of point A. Let's do the same for point B and for point C. So here is B. 1, 2, 3, 4 units above the red line. Now let's go 4 units below the red line. 1, 2, 3, 4. Here is point B prime. And now for point C. Just 1 unit above the red line, and so C prime will be 1 unit below the red line. And we can again draw lines to create a triangle shape. This triangle, A prime, B prime, C prime, is the reflection image of the original triangle, ABC. And finally, for part C of the question, find the coordinates of that reflected image. And we're just going to handle them one at a time. We have A prime and B prime and C prime. And so right here, let's figure out the ordered pairs for each. So A prime, in parentheses with a comma between. Let's see, where is point A prime? Here's the origin. We have to go to the right to the 5, and then down -2. And so it is 5, comma, -2. Now B prime. Here is point B prime. Now starting at the origin, we need to go to the right to the 3, and then down to the -4. So 3, comma, -4. And last, C prime. Starting at the origin, it looks like right 1 and down 1. And that is 1, comma, -1.